Hi everybody, this is section 6.3 and now we are going to look at ways to prove that a quadrilateral is a parallelogram. In the past section we looked at properties of a parallelogram. Now they're going to give us a quadrilateral and ask us to determine is it a parallelogram. And what we're going to do is we're going to start off by looking at the converse of the theorems we looked at in 6.2. And that converse basically, and you switch the if and the then. So now we have if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And the important thing here to note is both pairs of opposite sides have to be congruent, not just one pair, but both pairs. The next theorem is for the angles, and it says if both pairs of opposite angles in a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, both pairs of opposite angles have to be congruent. And now we have our consecutive angles theorem, and it says if an angle of a quadrilateral is supplementary to both its consecutive angles, then the quadrilateral is a parallelogram. All right, so here they want us to find the values of x and y in this parallelogram. Now, we know with parallelogram, opposite sides are congruent. Right now I have an x and a y here, so I really can't, have an x here and a y here. I can't solve that right now, but I do know that PQ and SR are congruent. So I'm going to solve that to find x. So I know that 3x minus 5 is going to be equal to 2x plus 1. Now subtract 2x from both sides. So it gives me x minus 5 equals 1. And I will add 5 to both sides. So x is going to equal 6. Now, that is going to help me find y, because if x plus 2 is equal to y, and I know that x is 6, I can just do 6 plus 2, and that's equal to y. So I know that y is 8, and I didn't have to really solve the equation. I did, but I just plugged in my numbers. So now we have the converse of the diagonals theorem, and this just says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if they bisect each other, then I know the quadrilateral is a parallelogram. All right, I also know if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So here, when we were looking at just sides, we knew that we had to know both sides were parallel. When we were looking at angles, we had to know that both pairs of opposite angles were congruent. Now, if I know that one pair of opposite sides are both congruent and parallel, so it has to be both things, congruent and parallel, then I know that that figure is a parallelogram. Okay, so now they want us to prove, and we're not going to do a proof here, but we are going to prove that this quadrilateral is a parallelogram based on the given information. So we have a pair of consecutive angles, and 150 plus 130 does equal 180. So we have a pair of consecutive angles that are supplementary. We also know that AB and DC are congruent to each other. So because we know this supplementary pair here, we can say that this quadrilateral is a parallelogram because the consecutive angles are supplementary. Now, if we look at this one and we want to prove that our quadrilateral is a parallelogram, this time I know that HI and HK are congruent. I also know that IJ and KJ are congruent. But they are not opposite sides that are congruent. So do we have enough information to prove this is a parallelogram? we do, and our information tells us that it is not a parallelogram because opposite sides are not congruent. So it is not a parallelogram. So it is not a parallelogram. All right, I thought this was cool to look at. We have a truck that sits on a vehicle lift. If you ever gone to the car shop, you've seen these before, I'm sure. And what it does is the arms raise the truck up so that a mechanic can fit underneath to work on the truck. Instead of putting it on a jack, which may not be stable, they can do this and work on it. And they want to know, why will the truck always remain parallel to the ground as it is lifted? So if you take a look and look at the picture here, okay, the arms that the lift is on, they're both 6 feet long. And the platform, which is parallel to the floor, is 26 feet long. So it doesn't really matter what this angle here or this angle here is. As they raise up, these two opposite angles are always going to remain congruent to each other, and these two angles will remain supplementary. So because opposite sides are congruent, it will always remain parallel to the ground because it will always be a parallelogram. And here's just a statement to kind of tell you the same thing that we just talked about in the last slide, so you can kind of see, again, all opposite sides will always remain congruent, so it will always remain a parallelogram and always be parallel to the ground. And that is it for section 6.3.